This is lesson 10.4 and 10.5. If two secants or chords intersect inside a circle but not at the center, double the angle equals the sum of the arcs. So for in, 2 times angle equals arc plus arc. And we notice that there are two different angles that they mentioned here. Angle 1 corresponds to these two arcs, AB and DC. And if I drew arrows pointing from the angle to those arcs, they match up. And angle 2 belongs to these two arcs. So you have to make sure you're using the correct angle with the correct pair of arcs for this to work, to do 2 times angle equals arc plus arc. So for example A, the angle I have points to the two arcs, so I could set up 2 times angle equals arc plus arc. So that's going to be 2 times the 128 equals x plus 154. So using my calculator, 2 times 128 is 256. And if I take away the 154, I get x is 102. In B, the angle I'm using goes to these arcs. So really the angle next to this x is a 180 minus x because they had to be a linear pair. So now this angle goes to these arcs, and I can use those now. So 2 times the angle equals arc plus arc. So that's going to be 360 minus 2x equals 130. Take away 360 from both sides. And now divide by that negative 2. And x is really 115. So here's some tries. Pause. Answers are posted online. If two secants or tangents intersect outside the circle, double the angle equals the difference of the arcs. So when it was inside, it was the sum, but when it's outside, it's the difference. And we're going to call one of them the outer arc and one of them the inner arc. And outer is going to be the one that's further away from the angle, while inner is the one closer. So if I'm talking about angle A here, BC would be inner and DE would be outer. They're all within the angle, and those are the two arcs we're using. We could ignore arc BD and CE. If I'm talking about angle A, it would be arc BC and DC as the inner and outer arcs respectively. This one, when it's two tangents, and we're talking about this angle, the outer arc and the inner arc are the only two arcs that exist in the circle, and I think I just said those backwards. The outer arc here, the inner arc here. So if I knew one of them, I could do 360 minus that number to get the other one. So that's very important to remember. So for example 2, we want to find the measure of angle L. I'm going to put a little x in there for myself to use it. And this is that scenario I just talked about. We know the inner arc is 102 degrees, and this circle is only made of those two arcs. So if I take 102 away from 360, I get 258, and now that is my outer arc. And now I can set up 2 times angle equals outer minus inner. So 2 times my unknown angle x equals the outer arc minus the inner arc. So 2x equals 156. Divide that by 2, x is 78. For B, actually I should have said the measure of angle L is 78. I'm going to go back and change that. Okay. For B, I'm looking for the measure of arc CED, so this outer arc here. I'm going to put an X on it. So 56 is the angle, 95 is the inner arc, and now X is my outer arc. So 2 times the angle equals the outer minus the inner. So 2 times 56 is 112. And now I just have to add that 95. And instead of writing X, I'm going to write the measure of arc CED. All right, and that's our answer. So here's some for you to try. You can pause. Answers are posted online. In example 3, this is like that first example 2 we had. We know the inner arc. We don't know the outer arc. And when I say we know the inner arc, we have something representing it. We still don't know the actual number of degrees, but that doesn't change anything. If I knew it was 10, I would do 360 minus 10 to get the other side. It's x, so I'm going to do 360 minus x to get the other side. And now this is just an outside problem where 2 times the angle equals the outer minus the inner. When you're dealing with x's, it might help to put your inner inside parentheses in case there's more than one term there, because then you would have to remember to distribute. In this case, there isn't anything to distribute, so it's not going to become an issue, but it is helpful for when it does become an issue. So now this will be 360 minus 2x minus our 360 and divide by 2. So here's a try problem. Pause. Answers are posted online. An inscribed angle is an angle whose vertex is on the circle and the sides are chords. And then we call the arc that angle opens up to the intercepted arc, right? It's the arc that lies in the interior of an inscribed angle. I like to think of it as you're holding a flashlight on the edge of the circle. This is the arc we're lighting up with our beam of light. If an angle is on the circle, whether it's inscribed or not, like in this case, or not in this case, double the angle equals the arc. So 2 times that angle equals this arc. 2 times this angle 1 equals this arc. 2 times this angle 2 equals this arc. So for this, we'd have to look at which side the angle's on to match it up with the right arc. For the inscribed, it's our light beam. So we're going to find each measure. The measure of angle x is here. That is an inscribed angle. The intercepted arc is 86 degrees. So 2 times the angle equals the arc. So the measure of angle x is 43 degrees. When I want arc yx, that's an intercepted arc. The inscribed angle was 52. So we're going to, again, set up 2 times the angle equals the arc. I'm just going to put the whole thing in here for now, because 104 will equal the measure of arc yx. Here's some for you to try. Pause. Answers are posted online. Example 5. We want to find the measure of angle QPR. So we're looking for this corner down here. It in fact matches the arc we have. So we could set up 2 times, I'm just going to use x again for angle, equals the arc. So cut it in half. The measure of angle QPR is 74 degrees. And here we want arc DEF. So we want this arc on this side. 64 is angle CDF. So if I started by finding this arc by doing 2 times angle equals arc, so 128 equals arc. These two arcs add to 360. So if I do 360 minus 128, we get 232 for the measure of arc DEF. Here's some for you to try. Pause. Answers are posted online. For example 6, the diagram shows the path of a light ray as it hits a drop of water. The ray is bent or refracted at points A, B, and C. If the measure of arc XY is 84 degrees, and the measure of angle B is 64 degrees, what is the measure of angle D? So what we can do is I'm going to ignore this over here, and I'm going to focus on the circle where I know angle B, because that angle B is going to allow me to find arc AC, because angle B is an inscribed angle and AC is its intercepted arc. So if I start out by doing 2 times the angle equals the arc, then 128 would equal the measure of arc AC. And now I have an outer arc and an inner arc with my outside angle. So here we're going to do 2 times the angle equals outer minus inner. So 2x will equal 44. Cut that in half, we get 22. So the measure of angle D is 22 degrees. If two on angles have the same arc, those angles are congruent. And it makes sense because let's say we knew that this angle was 60 degrees, that would make this arc double that, or 120. If this arc is 120, this angle would be half of that, or 60 degrees. So as long as they share an arc, as long as they're lighting up the same with their light beam, they're the same flashlight. If I want to find the measure of angle T, I know angle T and angle U are congruent because they both light up arc SV. So we could set 3x minus 5 equal to 2x plus 15. So x is 20. And now I'm going to put it back in. 3 times 20 minus 5. 60 minus 5. The measure of angle T is 55 degrees. Here's a try problem. Pause. Answers are posted online. A polygon is an inscribed polygon when all its vertices lie on a circle, right? Each point of the polygon is on the edge of the circle. And then we call the circle that goes around the polygon a circumscribed circle. If a triangle is inscribed in a circle and one side is the diameter, it's automatically a right triangle. And that makes sense because if this is diameter, this arc is 180. If this arc is 180, this angle is half of that, or 90. So it's automatically a right triangle. A quadrilateral is inscribed in a circle if and only if the opposite angles are supplementary. So that means E and G have to add to 180. D and F have to add to 180. Nothing has to be the same. They just have to add to 180. So for example, 8, if I want to find the measure of angle F, I know that this is a right triangle because the triangle is inscribed with the diameter being one of the sides. So the remaining two angles would add to 90. I could have added plus that 90 equals 180, but that's just an extra step. So I get 13x equals 91, and x is 7. So that means the measure of angle F, 28 plus 2, is 30 degrees. In B, we know it's a quadrilateral inscribed, so the opposite angles add to 180. So 95 plus y equals 180. So the measure of angle y is 85 degrees. And we know 60 plus x is equal to 180. So the measure of angle x is 120 degrees. These are the final ones for you to try. The answers are posted online, but that is the end of sections 10.4 and 10.5.